we're going to begin with example 17.1. A cart was moving along a straight level path with constant velocity of 30 meters per second. At t equals 0, it begins to decelerate, negative acceleration, at a constant rate of negative 5 meters per second, and I've written that as negative 5 meters per second squared. In part A, they ask what was the velocity of the cart at t equals 10 seconds, and in part B, what was its position at t equals 10 seconds. First, let me begin with a comment. I do not like this word decelerate. Urgh! Here's the reason I don't like it. Because in our common use of the term, we normally think that automobiles decelerate and then they come to a stop, and that's the end of the motion. The light turns red, I step on the brake, I decelerate. When the car comes to a stop, then the motion's finished. Frequently, and this is going to be an example of the case, in fact, the object only comes for a stop for an instant in time, and then it begins to move in the opposite direction. And so I think this word decelerate is misleading. I will discourage you from using it. I like the term negative acceleration better. All right, let's look and see what part A is asking us for. They're asking us for a velocity of the cart at t equals 10 seconds. In order to solve a lot of these problems, you need to identify what variables you know, what variables you're looking for, and then go up to your list of equations and figure out the equation that has those variables related together. So, in part A, they're asking us for the velocity at time t equals 10 seconds. We're trying to figure out what v is equal to. They told us at the beginning that the cart started moving with a constant velocity of 30 meters per second, and then it started doing something at t equals 0. So we can say that v naught is plus 30 meters per second. They told us that the cart has a constant acceleration of negative 5 meters per second Negative 5 meters per second squared. And these problems, to start with, are nice in that they give you the negative sign. In later problems, you're going to have to discern that the sign is going to be negative and put that sign in. But here, they give us this. One of the things they tell us is that the elapsed time is t equals 10 seconds. So now, we're looking for v. We have v naught, we have a, we have t. The first equation that I wrote down, v is v naught plus a times t. And this is convenient because v is already by itself the thing we're trying to find. So I'm just going to put in the numbers now. And I can do this one in my head. I've got 30 plus a negative 50, which is equal to negative 20 meters per second. In other words, after 10 seconds, this object is moving at a speed of negative 20 meters per second. Let me pause here for a moment to say that if I wanted to, I could graph this equation. I could let t be my horizontal variable, v be my vertical variable, and I have the slope of a line of negative 5 meters per second squared, and I could actually graph this. And here's what it would look like. Alright, so here's a set of axes. My initial velocity is plus 30 meters per second. My acceleration is constant. It's a slope of negative 5. At 10 seconds, my velocity was negative 20 meters per second. So 10 seconds down here, negative 20 meters per second down here. And so I'm going to have a line that looks like this. There's a velocity versus time graph of this particular motion. All right. Now we're trying to figure out part B. What was its position at t equals 10 seconds? Now I think this is a little bit awkwardly worded, and the reason is because they don't tell you what the initial position is, yet they ask you to find what the final position is. So I'm going to make an assumption, and my assumption is at time t equals 0 that the object, the cart, was at the origin. Now, as before, I want to see what information that I've got. Well, I know that the elapsed time is 10 seconds, and I know that the initial velocity was 30 meters per second. The object was moving with constant acceleration. The acceleration was negative 5 meters per second squared. And I'm trying to find what x is. So I see what information I've got. I look for the variable that I'm trying to find, and it looks to me like the second equation that I wrote down, x is x naught plus v naught t plus 1/2 at squared, will give that to me. So let me use that equation. And now let me feed in the numbers that I've got. And now I'll put these numbers into my calculator. I can almost do this without using a calculator. And I get that the final position is x is equal to 50 meters, which says that the object is 50 meters to the right of where it started, if the right is the positive direction, when the object ends its motion 10 seconds later. Now, that doesn't mean it's going to end its motion. It's going to have continued motion, but we're only interested in what happened in the first 10 seconds. So now let's go and take a look at another example. It's example 17.2. A car with an initial velocity of 30 meters per second began to accelerate at a constant rate of 2.8 meters per second squared. Part A, what will be the velocity when the car has traveled 200 meters? And Part B, how long does it take the car to travel a distance of 200 meters? Let's begin again with the variables that we know and the variables that we're trying to find. What will be the velocity? That means we're trying to find v. It has an initial velocity of 30 meters per second. That's v naught. It has an acceleration that's constant at 2.8 meters per second squared. Now they tell us the displacement of the car. In other words, x minus x naught. I'm going to again make the assumption here that let's let the origin be where the motion begins. In other words, x naught is equal to 0, and the final position is 200 meters beyond that point. So now, we have all these variables. It is the third equation of motion that relates these variables together. Now that third equation is written in terms of v squared. In order to find v, I am going to take the square root of both sides. Now here's a subtle point. Whenever I take a square root, I create a positive root and a negative root. Frequently, one of those roots will be realistic and the other one will not be. And in our case, we're going to discard the negative root. But nevertheless, that root is there, and sometimes it has physical meaning that you'll need to pay attention to. All right, so now I'm going to put in the numbers. And this one I cannot do in my head, so I'm going to pull out my calculator. I get that the speed, the velocity is 44.94 repeating meters per second. All right, part B, how long does it take the car to travel a distance of 200 meters? Now in this context, how long means how much time does it take? So I'm looking for time. What do I know? Well, I know that the initial position is 0, the final position is 200. I know the displacement, that 200 meters, the acceleration is 2.8 meters per second squared. I know the initial velocity. The initial velocity is 30 meters per second. And from the A part, I know what the final velocity is after that 200 meters. It's 44.94 meters per second. And I can use that to help me solve this part if I want to. Now again, what am I trying to find? I'm looking for time. Now I've got several different equations that might be able to help me with that. For instance, I could use the second equation of motion, but that one has time as a squared variable in it, and I would probably have to pull out the quadratic formula to figure that out. But the first equation is useful. I can say v is v naught plus at, and I know all of those variables I can solve for the time. Let me subtract v naught from both sides and divide both sides by a and get t by itself on one side. So if you'll permit me to do 2 steps of algebra in one, then that will save some space here. Now I can put in the numbers. I know all those numbers. And now I turn the mathematical crank, basically punching things into my calculator, and I come up with some number. and to two significant figures I get 5.34 seconds. And that solves this problem. Of course, the problems are going to get harder, but the idea is the same. Take your equations of motion, make sure that you've got constant acceleration before you employ them, write down the variables that you know, write down the variable that you're looking for, and then choose an equation or some combination of equations that will get you from what you know to where you want to go.